Hi everyone, it's Zihan, the TA of IE323. Today I'm going to show you some sample problems and how to solve them. Those problems are related to homework 1, they're similar, so I hope through this video I can help you to solve the problems in homework 1. And before proceeding this video, I hope you guys can take a look at those questions first, okay? First, let's take a look at this problem. If all possible samples of size 16 are drawn from a normal population with mean equal to 50 and a standard deviation equal to 5, what's the probability that a sample mean x bar will fall into the interval from this and this? Assume that the sample means can be measured to any degree of accuracy. Well, let's have more space here. First, from the problem setting, we can know the sample size is 16, and for the population, the mu, which is the mean, equals to 50, and the standard deviation equals to 5. Okay. So for the sample size of 16, we can know the mu x bar equals to 50, which is the same with this mu, and the sigma x bar should be sigma divided by square root n, which is 5/4, right? So from this we can get what we want the interval is mu x bar minus 1.9 sigma x bar, which equals to 47.625, and mu x bar minus 0.04 sigma x bar equals to 49.5. So from CLT, we can know x bar minus mu x bar divided by sigma x bar should follow normal distribution of 0, 1. So we want the probability that x bar fall into this interval. So let's make the middle of this part to this form. Probability is 47.625 divided by minus 50 divided by 5/4, less than x bar minus mu x bar divided by sigma x bar. So 49.5 minus 50 divided by 5/4. This should equals to probability minus 1.9, less than z. Z stands for the normal distribution. Okay, less than minus 0.4. equals to probability z less than minus 0.4 minus probability z less than minus 1.9. So we can get those two values from the probability table here. So here is the normal probability table. So we can find the minus 1.9. minus 0.0287. Here we need to find the minus 0.4. Here is the 3446. 0.3446. This will equal to 0.3159. Okay, so the first problem is solved. Now let's solve the second problem. A certain type of thread is manufactured with a mean tensile strength of 78.3 kilograms and a standard deviation of 5.6 kilograms. So we want to know how the variance changed when the sample size changed. Okay? So from the problem setting, we can know for the population, the mu equals to 78.3, and the sigma is a standard deviation. Okay, standard deviation sigma equals to 5.6. So we want to know how the variance changed. For the problem A, when the sample size n equals to 64. Okay. We don't care about the mu, okay? So we need to find the sigma x bar square, the variance. This equals to sigma square divided by the n. So it's 5.6 square divided by 64 equals to 0.49. So when n equals to 196, the sigma x bar square equals to sigma square divided by n. That is 196 equals to 0.16. So when sample size changed from 64 to 196, the variance of the sample mean will change from 0.49 to 0.16. So for the problem B, when n equals to 784, sigma x bar square equals to sigma square n divided by n. This is just the same formula with problem A, so I will speed up. So this equals to 0.04. And for n equals to 49, sigma x bar square equals to sigma square divided by n. It's 5.6 divided by 49. This equals to 5.64. So when the sample size changed from 784 to 49, the variance will increase from 0.04 to 0.64. Let's take a look at the third problem. The random variable x, representing the number of cherries in a cherry path, has the following probability distribution. This is the distribution. So find the mean mu and the variance sigma square of x. So for the problem A, we need to find the population mean and the variance. So mu, from the definition, mu equals to expected value of x, which is 4 times 0.2 plus 5 times 0.4 plus 6 times 0.3 plus 7 times 0.1, which equals to 5.3. And for the sigma square, from the definition, we can also know this equals to the expected value of x minus mu squared. So this should be equal to 0.2 times 4 minus 5.3 squared plus 0.4 times 5 minus 5.3 squared plus 0.3 times 6 minus 5.3 squared plus 0.1 times 7 minus 5.3 squared. This is equals to 0.81. So that's for the first problem. And for the second problem, find the mean mu x bar and the variance sigma x bar of the mean x bar for a random sample of 36. So now we get the sample size of 36. We want to find the mu x bar and the sigma square x bar. So the mu x bar should be equals to the mu. So it's 5.3. And the sigma x bar square should be, equals to sigma square divided by n. So it's 5.81 divided by 36. So this is 0.0225. So for the problem C, find the probability that the average number of cherries in 36 cherry puffs will be less than 5.5. So we want to find the probability x bar less than 5.5, right? And from CLT, we can know z equals to x bar minus mu x bar divided by sigma x bars, following the standard normal distribution of 0.01. Okay, so from this we can know probability x bar less than 5.5. We can transform this into x bar minus x bar mu x bar divided by sigma x bar less than 5.5 minus 5.3 divided by square root of 0.0225. So this is the probability z less than 1.33. So we can use the probability table to find out this value. So we want 1.3 as one, or is minus. We want the positive one. So here is the 1.30, 1.31, 1.32, 1.33. So the 9082 is the value we want. So this value equals to 0.9082. That's the answer for this question.